All right, so we're reviewing for our test tomorrow. You will have a formula chart on the test. You ready? Mm-hmm. Number 1 says write the quadratic equation in vertex form for this graph. You ready? So number 1, what we did last week when we had a problem like this, I didn't give you a graph, I gave you 2 points, right? I listed the points. So what we have to do is we have to look with our eyeballs here at this graph and find those 2 points. So the first point is the vertex. There we go, vertex. Where's the vertex for this parabola? 2, 0. That's your h and k value, right? I can do a better k than that. There we go. All right. Second, I need some other point on this parabola. Last week I just gave you a point. Right now I'm going to ask you, look at this parabola and find a point. So where's there a point on this parabola? Ooh, 0,4. Why 0,4? I love that point. Ooh, it's a y-intercept. It's got 0 in it, right? Both make that a very good point. Very nice. All right, so then that's my x and y value. So what we're going to do is we're going to plug this into the equation in vertex form, and we're going to solve for a. You ready? So remember, I'm going to scooch you over because we've got everything we need from the graph now. Yes, yes. Oh. How did you get this one? That's not. Ooh. Oh, because I had it on top and I was looking at it. Sorry. All right. So we're going to use the quadratic equation in vertex form. Y equals a times x minus h squared plus k. And that formula is on your formula chart. It's at the bottom with all the other quadratics. So let's plug in what we know. Do we know y? Yes, y is 4 equals, do we know a? No, that's what we got to solve for. Times x is 0 minus 2 squared plus 0. So I want you guys to use your calculator, or you can solve by hand. It's up to you. You could in-solve and solve for a. I want y'all to in-solve and solve for a. All right, you guys, what do we get for a?
1.
Woohoo! A is 1. So then I can plug in a, h, and k to that original equation now, right? I'm going to have y equals 1 times x minus 2 squared plus 0. That's it. Not too bad, right? All right. Number 3 is similar. I'm going to let you guys do 3. Okay? All right, number 2, y'all ready?
Yes.
2 is just like the back side of that quadratic assignment that was due today. The one you were working on, Robin? That one. You ready? It is. So there's 3 steps. If you're going from vertex to standard form, there are 3 steps, you guys. You've got to FOIL, distribute, combine like terms. Okay? Y'all want to do it in those 3 steps? We're going to FOIL, distribute, combine like terms. You ready? So first, I've got y equals 2 times x minus 3 squared. So we're going to start with that one to FOIL, plus 5. So I've got y equals, y equals 2 times x minus 3 times x minus 3 plus 5. Yes? All right. So we're going to FOIL. So I've got y equals 2 times, so x times x is
2x.
Oh,
X
x squared. Beautiful, beautiful. X times negative 3. Negative 3x. Negative 3 times x. Negative 3x. And negative 3 times negative 3.
9.
Positive 9. Very good. plus 5. So that's the first step. We FOILed. Right? Now I'm going to distribute. I'm going to have y equals 2 times x squared. 2x squared. 2 times negative 3x. Beautiful. And again, 2 times negative 3x. And one more term, 2 times 9. Plus 5. So now, I've got to identify my like terms. You ready? Negative 6x minus 6x.
12.
Negative 12x, perfect. And 18 plus 5. And we bring down that first term because it didn't have anything alike. That's it. Standard form. Yes, ma'am. Then that's like a negative 1. So then instead of distributing 2, you would have distributed negative 1. Good question. Very good question. I threw one of those tricks on the assignment last week, didn't I?
Could you combine the negative 3x and negative 3x before?
Yes, you could have combined those in one step. I was trying to make this as few steps as possible. That would have eliminated a line. I realized that last week after we did these, but no, I'm one of those people that too. I'm like, oh, I got to combine like terms before we can move on.
Yeah, that's what
Yeah. But it doesn't matter if you combine now or combine later, you'll get the same answer. Yes, ma'am. Then it's 1. Mm-hmm. All right. How do y'all feel about 2? Is that a little better than last week? Y'all see how I eliminated a step? A little better, right? Less writing, everybody's happy? See a few pencils still moving. I'll give y'all just another second. And we're going to take a look at number 3.
Is the test like this?
Looks pretty close. So let's take a look at number 3. You guys, I said earlier that 3 was a lot like number 1. It's just a little different. You ready? So number 1, I gave you a graph. Number 3, there's no graph. The directions are similar. It says write an equation in vertex form, right? But here our vertex is negative 2, negative 2. Hey, they gave us the vertex. Those are my h and k. But here it says f of 0 equals 1. I have to identify what's x and what's y in that equation.
X is 0.
X is 0, beautiful. And y is
9. Why did I say 9?
1, right? Because normally we have f of x right here, right? Right, Xavier? That's normally f of x. So x is 0.
0.
Right?
Yep.
Equals y, 1. Yes? Yes? All right. I'm going to give you guys a moment. I want you to solve for a. I want you to set up and write an equation, solve for a, and then write the equation in vertex form. And we're going to check it, okay? I'm going to give you guys just a moment. All right, so I'm going to go through this kind of quickly because I saw most of you have got it. So you started with the equation y equals a times x minus h squared plus k. I saw a lot of you right. Okay, your y was 1, so 1 equals a. Don't forget when you end solve, you have to tell it times before the parentheses because remember, your calculator's not very smart, right? You're smarter than the calculator. All right, so 0 minus a negative 2 squared plus negative 2 or minus 2. So could I have put right here plus negative 2? I saw some of you do that. Is that okay? Yeah. Yes, definitely, but this saves a little bit, right? And Xavier, you did a beautiful job here. Instead of minus negative 2, what did you put? So what's minus and negative?
Oh, positive.
Positive. You had it right there in front of you. Plus 2, right? Because your x's lie. Exactly. Exactly. So what did you guys get for a?
0.75. Yeah.
0.75. Or I saw some of you do the fraction. What's the fraction for 0.75? 3/4. Beautiful. Beautiful. 3/4. Very good. All right, so then you can take your h, k, and a to write the equation. So you're going to have y equals 3/4 or 0.75, right? Times x. Well, h is -2 and your x is lie. So are we gonna write x minus 2 or x plus 2? Plus 2 squared. And k is -2, so minus 2. Is that okay? If you put the decimal here, 0.75, that is fine. That is acceptable. Okay? But what if you'd gotten
Wait, why would you put an X? Why wouldn't you just put 0?
Because remember x and y. X and y, that's for all of the x's and all of the y's on the parabola, remember? So if you put 0 and 1 instead of x and y, because that stands for all of the points on the parabola, not just one of them. Okay? All right, real quick, you guys, question. I have a question. What if we'd solved for a in the calculator and got something like 0.1111111111111?
Write it.
0.1.
Ooh, you could put 0.1 repeating, or you can convert it to a fraction. Remember menu, number, and then I think it's 2 or 3 goes from a decimal to a fraction. Okay? If you have trouble with that tomorrow, let me know. I think there's one repeating number, one repeating decimal tomorrow. All right. Number 4. Number 4. This is a problem from a release test, you guys. This is a real star problem. Real EOC problem. You got this. You ready? You ready? It says the graph of y equals 3x squared minus 2 is shown below. If the coefficient of x squared is changed from 3, see how we have a 3 here, to some other positive number to create a new function, how will the graph of the new function compare with the graph of the original? So let's pick another number that's not 3. What's another number not 3? 4. So let's graph y equals 4x squared minus 2. So I want you in your calculator to graph both of these first. Well, 3x is your first one. Where did we get 4x? That's a good question. I need you to listen and not talk. Someone else picked it. Because look. It says, what happens if you're 3? If we change 3 to some other positive number. So could we have chosen a different number other than 4? Could we have done like 12? Yeah. Could we have done 0.1? Yeah. We could have done 5. Anything that's not 3. So I want you guys to graph both of these, and we're going to compare. It got more narrow, right?
Yes.
So if I sketch this here, ladies, gentlemen, if I sketch this here, it's, I'm going to zoom in here so it's easier to draw, sorry. So if I sketch this, it looks something like this, right?
Yep.
All right, so let's look at our answer choices. X says the x-intercepts of the new graph will be the same as the x-intercepts of the old graph. Well, x-intercepts are where those lines cross the x-axis. If it got more narrow, my x-intercepts get closer together, don't they?
Mm-hmm.
So does that mean that they're the same?
No.
So can A be an answer?
No.
Cross out A.
Hey,
B. It says the vertex of the new graph is different. Is my vertex different?
Yes. Yeah.
no.
No.
Yeah. It's a -2.
C says the new graph will be more wide or more narrow than the original.
Yes.
That happened, right? I'm going to read D just to be sure. D says the new graph will open in an opposite direction. No, because they're both opening up, right, Lena?
Yeah.
So it's got to be what?
C.
C's got to be your answer. Or cheetah.
Or cheetah.
Cat. All right. Number 5. Hey, number 5 looks a lot like the warm-up from Friday. Hey, look at that. Look at that. So 5 says, the table shows some ordered pairs that belong to quadratic function h. What is the range? Well, what tells me the range? The x's or the y's? It's my y values, right? So let's look at the y values here, you guys. Well, first, where's my vertex?
0, 1.
Oh, no, we're looking for that middle. So look. My my y values go 41, 17, 1, -7, -8, -7, 1. So where do the numbers stop and turn and go back? 3, -8 is my vertex, right?
Yes.
So now look at the other y values. Are my y values all bigger or smaller than 8?
They're bigger.
They're all bigger.
Yeah.
Oh, wrong pen. Here we go.
Oh, what the heck they are?
Bigger than, -8, sorry. So let's look at our answer choices. A says all real numbers. Okay. B says all real numbers greater than or equal to -7. All real numbers greater than or equal to -8. D is all real numbers greater than or equal to 0. C is the one that matches what we just said, right? So C, all real numbers greater than or equal
See, as again.
to -8. How are we doing so far?
Good.
Pretty good? Pretty good? All right, let's take a look at number 6. Number 6. Number 6. 6 says, okay, this one I know. I'm seeing in your faces already. You're looking at it, you're like, that's a lot of reading.
Whoa.
Watch, it's not as bad as it looks. You ready? All right, so points 3, 2, and 7, 2 are on the graphs of both quadratic functions f and g. The graph of f opens downward, so that means that it's pointing down, it's got a maximum, right? The graph of g opens upward, and I want to know which of these statements, 1, 2, 3, and 4, are true. So what I'm going to do really quick is I'm just going to sketch that description. Just a really brief sketch. You ready? Okay. So we've got a point at 3, 2, right here, and 7, 2. Right? All right, it says F contains both of those points, so that means my parabola goes through both points, right? And it points down is what it says. And G points up, right? Seven, 2. Just a sketch. Doesn't have to be perfect.
Like that?
That's beautiful.
Oh, man.
All right. Description number 1. You ready? Description number 1. You ready? Says the graphs of f and g have the same axis of symmetry.
Yes. No.
They both don't have the same axis of symmetry. What if I drew a line right down the middle?
Yes.
They have the same axis of symmetry, don't they?
Yes, they do.
Yes, they do.
Wait, why is there 2 B's?
Oh, the second one should be a C. I'm sorry. Good eye. This should be a C. There we go. All right, so more than likely answer choice A. Let's take a look at answer choice B. 2 says the graph of f and g have the same x-intercept.
No.
No, they do not cross the the x-axis in the same places, do they?
No.
Could they? Maybe, but the example we found didn't, right? And if you can find at least one example, it's not true. All right. So then it's not 2. So right there, I can go in and eliminate any answer that has 2 in it, right?
Yeah.
So I can eliminate B
Yeah, why are there 2 B's?
and C.
Oh, no. Sorry.
Typo, sorry.
I forgot.
All right. So look, my only answers left are 1 or 1 and 3, right? So let's see if 3 is true. 3 says the graph F has a maximum point and the graph G has a minimum point. Is that true?
Yeah.
That's true. So it's got to be D. Do I even have to check? Do I even have to check statement 4? No. There we go. It's got to be D. It's got to be D. Is it an emergency? Okay. All right, number 7.
One emergency, one semester.
Per semester, per 6 weeks, right?
No.
No.
Semester.
2 6 weeks.
No.
3?
For the rest of the year. 7 says a graph of f of x is equal to 6x squared minus 11x plus 3 is shown on the grid. I want to know what is the solution to f of x is equal to 0. Yes, ma'am. Oh, you could. We could plug in 0 for f of x, right? But what does f of x stand? What does that 0? That's the y value, right? So it's asking when y is 0. I'm going to zoom in over here. When y is 0, so that's here, right? So when y is 0, it's any of the points that are going to lay on the x-axis. How many points do I have on the x-axis? 1, 2. So let's take a look at our answer choices. A says 1.5. Is that one of those points? Well, 1.5 is between 1 and 2, so possibly, right? Maybe? I'm going to write a question mark just in case. All right, what about 4?
No.
What about 1? No, that's in between those two, right? What about negative 2? No, so it has to be that A, right?
Just give you extra information. Because it's possible.
Mm-hmm.
Yeah, I know.
Come on, get it together. Don't be doing that.
Number 8. You ready for 8? 8 says, which function's graph has a vertex at positive 3, positive 5, and contains the point positive 5, positive 3. So remember, these are all in vertex form, right? We've got y equals a times x minus h squared plus k. So here, if my vertex is 3, 5, what's my h value? 3. And what's my k value? 5. So let's go through and see if we can eliminate any of those answer choices. See, y equals 1/10 times x plus 3 squared minus 5.
Would that mean that 5 is y and 3 is
That should be a minus 3, right? Because x is due what?
y?
Lie. So let's go and eliminate the two answer choices that have x plus 3. So that's A and D.
You said it lied when you didn't tell us.
Let's see. Say it again.
If you said it lied, why wouldn't it be close? If it was already
Because you're, well, this is the part that lies. That's the liar.
Yeah, so wouldn't it be
Mm-hmm.
close?
No, because this is already positive. So you're plugging in positive 3. So that's x minus positive 3. If it were a negative 3, that's minus a negative. That would make it positive. Sorry for the confusion. All right. So then K is positive, right? So look at your answer choices. I've got an minus 5, and a plus 5.
C.
You got it.
Nice.
That's it.
Okay, I still.
All right. Number 9. My directions say, oh, sorry. Tell whether the vertex, you guys, I'm not going to shout over you. Tell whether the vertex is a minimum or maximum point. And identify the minimum or maximum value. Tell what the y-intercept is.
So we just put it on the graph.
And the axis of symmetry. Yes, we could graph this. So let's graph this. So, number 9. Oh, the first one, there's 2 of them. Let me zoom in. So the first one is x squared minus 6x plus 8. So you could graph this in your calculator. Definitely. Definitely.
It's wait, is maximum going up or down?
Ooh,
It goes down, right?
good question. Maximum is if it's pointing downwards. You got it.
So then, yeah, this one's a minimum.
So this one's a minimum because this one's pointing up, right? So this one has a minimum value. I'm going to write minimum.
And then can't you find out the vertex?
Yes, so there's 2 ways to find the vertex on your graph. Well, actually, there's 3. So the first way is just kind of looking with your eyeballs, but that can be kind of difficult, right? The second way, you can analyze. The third way, Ryan, is using the table. What do y'all want to do? Analyze or the table? Table?
1.
So Control T. You're going to look for the middle. 3, -1. You got it. So your vertex is located at 3, -1. Because look at your table. See, above and below -1, you have 0. Above that and below that, you have 3. That's the middle of the table, right? Axis of symmetry. This one's very, very, very important, you guys, because if you only give me half of it, I can only give you half the points. Where's the axis of symmetry for this parabola? Remember, your axis of symmetry is the x value in your vertex.
Oh, it's
X value.
3.
3. What about 3? Because it's a vertical line, right? So we need the equation for that line. The equation for a vertical line, bless you.
Thank you.
It's x equals 3. X equals 3.
Wait, why is it 3? How did you say
Oh, wait, is it the x value in the vertex?
It's the x value of the vertex. Yes, ma'am. All right, finally, the y-intercept. How can I find the y-intercept on a table?
0?
When x is 0. Here, when x is 0, what is y? 0, 8. We got a maximum for the second one.
No.
Where's your vertex located? 1, 5. So what was your axis of symmetry? X equals 1. Very good. And then finally, where does it cross the y-axis?
2.
So how do I write that as a coordinate
0,
point?
2.
0, 2. Very good. There's a question just like this tomorrow, you guys. Just like this. All right. I got 1, 5. All right, number 10. This is from the notes on Friday. This is from your notes on Friday. The A value is going to change your vertical stretch or compression. you should be able to, this is harder than the question. I'm going to give you two equations. You can graph them.
Is that an impression?
Compression, sorry. It's a C, compression. It also tells me if it's negative A, we'll flip it in the x-axis. Right? That's a reflection in the x-axis. Pression, compression. All right, B, remember your marshmallow in the parentheses? That's that horizontal stretch and compression. Bless you. And a negative B will be a flip or reflection in the y-axis. All right, what did C do? It moved the function left and right. Beautiful. What about D? D moved the function up or down. So finally, E says, what conclusion can we make about the variables of C and D together? What special point is this on the parabola? So if C moves the function left and right, and D moves the function up and down, that's your vertex. Because your vertex tells you if you're moving left or right or up or down, right? So CD, so I'm going to put here CD is HK, the vertex.